So hello everybody and welcome to today's ODTN use case team call. Thanks for joining. It's been quite some time, but I'm happy that everybody could come back, and we have some interesting topics on the agenda for today. And thanks for Alessio for coming and presenting here about this. But if you have any more topics that you would like to add to the agenda, please do it on the agenda itself that I'm sharing on the screen, or add them at when we finish talking about these. We can always go for those at the end of the meeting. Okay, so first of all, I'd like Alessio to give an update on the current effort that Metro and ADVA are putting together for the extending even further the existing ADVA driver to support even not just optical connectivity intent, but optical connection intent. If I'm not mistaken, forgot the name. That enable line to client side through the flow hood programmable in basically one shot. The higher level intent goes from line to client in every transponder, and then the optical connectivity intent goes and configures the line side ports with wavelengths across the ROADMs and or the line system, and then to the other transponder. Alessio, feel free to present, and then you can take it from me.
Yes, thank you, Andrea. I'm not very familiar with the tool. I don't know if I can share my screen.
Yeah, you should be in the bottom. Should be a green button, share screen, or the top.
Yes,
or
I see. Okay.
Like
yes. Let me. Share this full screen. Can you see?
Yes, we can. A Windows 95
okay.
background.
Yeah. Okay, so this is just a quick update on the work that we are doing with ADVA within the Metro project. This work is planned to be deployed for the last demonstration that will take place in Berlin in the HHI premises in July, if I will remember. Essentially, there we have this testbed, including two quad-flex transponders and an open line system that is composed of 3 ROADMs. And this specific work is to essentially coding the driver for controlling the quad flex, and to be able to configure both the optical connectivity and the optical circuit intent, so including the association between the client port and the line optical port. I already so we have this draft patch that is uploaded on Garrett, and it's now in a quite advanced state. Also, it is still draft, so it is not public, but Andrea had already provided some comments, and we are in phase of testing it in the deployment that is in Berlin in HHI, and also Jose, that is the ADVA guy that working more practically on the driver, already tested it in another lab deployment, and it is almost working fine. Yes, this is the point. Essentially, we have implemented the terminal device discovery and the terminal device flow rule programmable. For the terminal device discovery, we did only very few modification with respect to the one that is already available in the master distribution, because of some changes that in the in this last period occurred to the OpenConfig specification, and because of some assumption that are made by ADVA in their transponder. While most of the work has been done in the terminal device flow rule programmable behavior, where essentially we have integrated all the logic of the ADVA of the ADVA transponder in the creation of the logical channels, because to establish this kind of connectivity, so many logical channels are created, and therefore the association between the client side and the line side is not so immediate. It's not so simple. So we have some intermediate steps to be correctly executed, addressing the correct association. And this is our current state. I have nothing else on this point. Andrea, I don't know if there are questions. You have seen the patch also.
Yeah.
We are also going to address your comments before releasing the final version.
Okay. Yeah. No. Sounds good. The patch looks good, and I think that it will showcase also some of the changes in the OpenConfig, as you said, for others to follow in and when needed. So I'm happy with that. And thanks for creating it. I don't have any more questions, but does anybody else have any questions or thoughts that want to share?
Yeah, here's Gert. Just wondering, does the demo also include a past feasibility check?
Excuse me?
Something like a PCE thing.
Can you repeat? I did not hear.
Does the demonstration also include a past feasibility check before it is provisioned?
The past feasibility, in which can you provide some more details?
Yeah, I mean, outside the demo setup, you typically would need to understand whether it's feasible to have an end-to-end connection between the two transponders.
Yeah.
From an optical perspective, you know, signal-to-noise ratio and so on.
Yeah.
Before you're going to set it up. And I was just wondering whether this kind of pre-calculation of the past feasibility is part of it. Yeah.
No, this I understand. So this is not included in the driver, because in my opinion, this is something that should operate during the intent compilation, no? So, and it's something also related to the selection of the modulation format, to selection of the path also. So it's something that is not to say included into the driver.
Okay.
And this is my opinion. I don't know if because obviously there are some effects. For example, for considering the modulation format, for example, is something that then have an effect also on the driver, because at the end of the day, it's the driver that has to communicate the proper modulation format to be used. But in my opinion, this is something that should be predetermined before calling the driver. So during the intent compilation, the path computation, and so on.
Okay.
If I may intervene here,
yeah.
It is true that the flow rule programmable driver that Alessio is using can be used with the demonstrations that we have made with, for example, GMPY. It's the same path through ONOS, and that shows the proper level of abstraction that ONOS has. Because on the northbound, when we add a flow rule, that goes to the flow rule programmable independently of how it's implemented. So what Alessio is proposing here with that terminal device flow rule programmable is usable through that implementation that we have done, for example, for GMPy for the TIP Summit demo. So you could use it with that. I don't think Metrohall is doing it right now, also because they're at the end of the project and they need to finish their stuff. But it could be definitely a possibility for Metrohall 2 or something like that.
Yeah, that was also what I assumed to be. It was just wondering if there was more behind than what has been explained here. Thank you.
Yes, but I have a question on the setup of the demo. You rely on the open line system controller of ADVA in order to establish, I think, to define the open line system path between add-drop port of the edge ROADMs. Right?
Yes, yes. This is not my my very field of knowledge, but I know that essentially yes, we are using the TAPI controller provided by ADVA, and the path is selected by the TAPI controller itself. The ONOS essentially talks the TAPI with the TAPI controller. And it is able in some way to understand which wavelength can be used on the ROADMs, because this is an important information because it has to be configured also on the transponders. But for example, for the path, so this is completely, I guess, implemented by the TAPI controller of ADVA, yes.
But that's the point. In fact, it is the responsibility of the ADVA OLS controller to check the feasibility of the path that is requested by ONOS. Okay, yeah, it's clear.
Awesome. One thing from my side, if that demo can be recorded, Alessio, I would be very grateful, and I'll be very happy to post on the ONF channel for everybody to see, as we have done in the past with other demos. So let me know.
Yes, probably we have to produce a video also for the project review. So for sure, I guess we have to ask Ramon and the rest of the project, but for sure, I guess we can share the video with you to promote also the Metrohall activity in a different environment.
That's great. That's perfect. That's exactly what I'd like to happen. Okay, great. Any more questions on this while we're here on this topic? No? Okay, then if not, the next topic, still with Alessio, is a proposal related to some findings that during the development of this demo and the Metrohall project came into light regarding the requirements for understanding what is the mapping that is existing between a client-side port and a line-side port. At the moment, what was done is that it was assumed that either there was a one-to-one mapping, meaning that the client-side port was mapped to a one line-side port, and it was done through the ports annotations, or there was no assumption at all, and ONOS could just pick any input and output port. Obviously, that wouldn't work because it's clearly not that way within optical devices. So what Alessio and the folks are proposing is to create some sort of behavior that allows you to map one-to-many input to output ports. I'll let you take it from there, Alessio.
Yes. Thank you, Andrea. Yes, essentially we faced this problem developing this driver because for the first time we tried to establish intents using real commercial transponder with many client ports, many line ports, and many slots, so many active transponders in the same node, no? So since ONOS essentially is seeing the single node, if you have many slots, it is assuming, except for the case of a static map that mentioned by Andrea, so it is assuming that you can go from each input port to each to any line port, no? But we know that this is typically is not what happens in real devices, because typically we may have many constraints, connectivity constraints, and this is true not only inside the transponders, but also inside the ROADMs, because you can have a connectivity matrix that is not fully connected. So you can, it is possible to have that, to have a limited set of output ports that are reachable from an input port. So the proposal here is, this is something that it is still in very first phases, and I would discuss with you the proposal to collect possible inputs also. So my idea was essentially to create, as Andrea mentioned, a dedicated behavior that we could call, for example, internal connectivity or something similar. And this behavior should be used during the intent compilation to understand if from a specific input port you can reach a determined output port or not. And this should be implemented, in my opinion. So using this approach, so having a specific behavior, we can separate the two implementation phases. No? So we can start assuming that we have this behavior for each device, so we can integrate the utilization of this behavior inside the core, we can say, or the methods, the part of the ONOS that perform the compilation of the intent. And then we can implement the behavior for each device that we want to use. For example, for the open ROADMs, we know that this kind of information are also modeled in the Young model of the device. So we can, for example, develop an open ROADM driver, or we can extend the open ROADM driver that we already have with this new behavior, taking into account the internal connectivity that we have in the nodes. So up to now, I only studied a bit, had an overview of what is in the code up to now, and this is what I discovered just today. Is what also mentioned Andrea. This is the optical. This is part of the optical circuit intent compiler, and this is when the optical circuit intent has to be associated to an optical connectivity intent. Something similar is already in place, because we see that here, when you have to essentially select the optical connectivity intent to use, you are checking if you are allowed to use this. But this, as mentioned by Andrea, currently it is implemented only utilizing the port annotation in case you have this static port that is simply a shortcut between one input port and one output port. So the idea is to extend this point for using the behavior that we are going to create. So checking this behavior to understand if this connection is allowed or not. So for the circuit intent, I guess the work to be done is not very complex, because the integration is already configured like here. is already coded here. So what you have to code is instead of using the annotation here, you have to call your behavior, while for the compilation of the optical connectivity intent, so the one that is the proper light path, we can say, so the configuration of the line side of the transponder and the ROADMs. So I did not find this kind of integration. Indeed, the part is simply computed calling the topology service we see here. And so maybe here the integration is a bit more complicated, but I'm pretty sure that it's something that is not very complex to do. We can integrate this new behavior at this level to check if the connectivity is allowed, doing something similar of what we have seen for the circuit. And nothing else. This is the stage, so we have not a patch, we have not code, we have only this idea to start working on this topic. And I would collect if you have some suggestions, or also if you consider that this is something useful to be implemented.
So maybe I can comment on that one a little bit, but there's a lot of connotation. I think there's an IETF draft on modeling the connectivity matrix.
Mm-hmm.
And a few, at least former ADVA folks, were also involved in that. So I assume ADVA knows them pretty much in detail. So maybe you can reach out. The other one is there's a pretty ugly effect in coming up. So if you think about, say, a ring of ROADMs with 10 nodes, and so you have two types of interfaces. One goes west and one goes east.
Mm-hmm.
And let's say on the west side, you're directly connected to where you want to get, and on the east side, you need to go through 9 hops in order to get to where you want connected. So when you run this check, both will say, yes, I can do it. The only difference is if you're connected to the wrong side, you either have 1 hop, or on the other hand, you have 10 hops, and there's nothing you can do about it. So that's an effect that should be visible more on the service. Let's say when you start the service, it's nothing to do with the driver. That's something that somebody who is trying to set up the things is obviously need to see, and it's hard to do if you're in TAPI you don't know which route it takes. I don't know if I was clear in the explanation.
Yes. So let's be sorry, I lost with the
Windows 95. I like that.
Yeah.
You should use an Apple II.
Yeah. I guess I can stop to share the screen because I have no other stop share. Okay. Yes, I agree with you. So thank you for the suggestion. So we can check the ATF draft just to get inspiration on how to implement this connectivity metrics. And yes, then I agree with you. Then this kind of information should be used during the path computation, because they may have an effect on the path that should be selected. And this is indeed what was my idea, no? Because the idea is to use the driver to retrieve this information and to store this information locally into the ONOS system, so that this can be dynamically checked during the path computation or the path selection. Also, I understand that could be useful, for example, to how to say, to not keeping this information at the level of the driver, but how to say, in some way to store it more inside the topology service. But I guess that using a driver instead for start is a good starting point. Using the driver to retrieve the information, then you have the information available there. You can use. Maybe it isn't the most effective way, but is a good starting point, I guess, because you can start to consider this kind of connectivity information during the path computation. Then I agree with you that this could be, how to say, could be abstracted in a more deep, to say, and to be deeply integrated with the topology service.
Yeah, I mean, if you put it in the driver, you basically get a yes/no answer. So
yes.
Yeah, can do it or cannot. But I think the place where it belongs is really in the path computation.
Yeah.
This is where I say it's good or bad.
Yeah.
It's not sufficient to have a yes or no.
For sure, I understand this is not the most effective or most optimized method, but I guess we can start like this, and then we can think after, for example, as we do for the port that we load using the driver, and then we abstract the port and we integrate the port into the topology vision. So we can think if we can abstract this kind of internal connectivity more inside into the topology service to use to say a more detailed and effective path computation.
Yeah. So sorry, I need to leave now. So thank you very much. I think
thank you. Thank you for feedback.
Yeah. Bye.
Bye. If there are other.
I think the proposal is very good, and I like the fact that this is then used in path computation. It should definitely be exposed in some way, definitely through the behavior, but at least maybe also something like a CLI command, something like the lambdas. There's like show lambdas, show available lambdas, something like that. And possibly even a UI in the future. We could extend the existing optical UI to have another tab that provides this type of information in the stack using that matrix. And I think that would be useful.
I have a question. Sorry, because I'm not very well. I am not deeply coding inside ONOS. Sorry, but your topology service is it stored in a data store? Is it associated to the data store where the topology that is composed of link and nodes are also there or not? Is my question correct? Is my question clear? The topology service you are referring here, what model it is using? Is it TAPI topology service?
No, the one we are mentioning here is the internal ONOS topology model.
Okay.
Yes, and at best of my understanding, also I'm not very expert on this, but at best of my understanding, it is a simple network graph, where each device is a node and each link is an edge. So it's not considering more accurate information regarding, for example, I don't know, optical impairments and so on. And also it's not considering internal connectivity inside the node.
Mm-hmm. Mm-hmm. So this is what you can export as a topology through the northbound through the REST interface of ONOS.
Yeah. Yes, Andrea. What do you think?
Okay.
It is, but we can also export it to TAPI. There is the northbound extension of TAPI allows us to translate basically from one model to the other, and that allows us to go back and forth. I am not sure if TAPI has the knowledge to provide this mapping. We would have to consult some TAPI expert for that. But I do believe that we can do it if TAPI supports it. That is what I'm saying. If it doesn't,
if you can
then,
map okay. You mean if you can map the TAPI topology service models, you can after that it's a matter of to do the mapping from ONOS internal topology to TAPI topology models and to export it. This is what you are saying, right?
Yeah,
if I understand. Okay.
Yes.
Now, the great advantage to do that is that you will provide some open interface that is basically interested by some operators. Okay. Okay.
Yeah, I know it is definitely important to do it, although I am. It's always a matter of resources and time. And,
yeah, I see. I understand. Yeah.
So that's really it. But apart from that, I think it's doable. It's not even that complicated. Having said that, I don't know if TAPI supports it. If it does, it shouldn't be too complicated. If it doesn't, then we would either have to expose it as an ONOS specific thing or look at possibly expanding TAPI for this specific case.
Yeah, hello. From what I understand, I think TAPI model supports this one. And for example, at the terminal device, at layer 1, we have the notion of node rule group that gives you the ability to declare the forwarding rules, and from that you can easily declare the destination port that one source port can connect to. So from that, I think it's a way to declare the connectivity, the candidate path. I think.
I see. No, so that's pretty good. Then we should take I should take a note of that. Okay. That perfect. Anything else on this point before we move on? Okay. Then if not, I don't have any TAPI updates here. Hui, is there anything notable that TAPI is going to? I know that you're going to the hardening LTS version. Apart from that, anything notable that we should be aware of?
No, sorry, not from my side.
Okay. I also don't have any other particular update on the project in general. I think there is still some good effort ongoing at ONF specifically. There, as you guys know, there is some. We are mostly focusing on SIBA and Volta and 5G projects, but I think we're still doing some great work here, and we're still keeping up the collaborations. So I would say let's move forward with Alessio's, for example, Alessio's proposal, if everybody's okay with that. So on that set, Alessio, would you mind starting whenever you have the time, or Metro Hall has the time, starting maybe a behavior proposal, just the interface to upload to the ONOS Gerrit, so we can have a look at the behavior interface and discuss that one. And after that one, you can provide a first draft implementation. Would that work?
Yeah, sure. Yeah.
Okay. I don't think there is any pressure of time, so I would leave up to you to decide whatever time works best for you guys. I would suggest to create a Jira ticket to track this.
Sure.
So we also know what's going on in the project. Yeah, but apart from this, I think we're pretty good and in pretty good shape to take the next steps further on that. Regarding the driver, I would say that as soon as you can, as soon as it's okay for the project, to please make it open.
Sure.
Touch.
Yeah.
So everybody can take a look at it and can comment on it. I'll make sure to put some more comments on it as soon as I can. But that's it on that point. So that was all I had. Anybody has any other questions, thoughts, comments? Okay, then if not, thanks everybody for joining, especially thanks to Alessio for presenting these two great topics and for bringing up these for discussions. That's much appreciated. Thanks for the great work, everybody, in the background and in all the time that you're still spending on the project and in the collaboration. Please do let me know if there is anything I can do. As usual, you can always feel free to reach me. Then I'll wait for the interface patch and the openness of the draft patch, and then I'll try and send an email out to everybody advertising the fact that we did open those. And if anybody has any update from the TAPI group, please do send it to the mailing list or to the Slack channel, and I'll make sure to get it out as soon as I can. Thanks, everybody. I'll publish the recording whenever I have some spare time. It's going to be in the next few days. Okay. Thanks a lot.
Thank you.
Cheers. Take care. Bye-bye.
Thank you. Bye. Bye.
Goodbye.